Machine learning model evaluation is the fifth topic in the third unit of artificial intelligence and machine learning. Model evaluation is the process that uses some metrics which help us to analyze the performance of the model. Model development is a multi-step process and we have to check how well the model generalizes future predictions. Evaluating model plays a vital role so we can judge the performance of the model. The evaluation helps to analyze the model's key weaknesses. There are many evaluation parameters out there. Examples are accuracy, precision, recall, F1 score, area under curve, confusion matrix, and mean square error. Cross-validation is one technique that is followed during the training phase and it is a model evaluation technique as well. Cross-validation and holdout. Cross-validation is a method in which we do not use the whole dataset for training. In this technique, some part of the dataset is reserved for testing the model. There are many types of cross-validation, out of which k-fold cross-validation is mainly used. In k-fold cross-validation, the original dataset is divided into k subsets. The subsets are known as folds. This is repeated k times where one fold is used for testing purpose. Rest k minus 1 folds are used for training the model. So each data point acts as a test subject for the model as well as acts as the training subject. It is seen that this technique generalizes the model well and reduces the error rate. Then holdout. It is the simplest approach. It is used in neural network as well as in many classifiers. In this technique, the data set is divided into train and test data set. The data set is usually divided into ratios like 70:30 or 80:20. Normally, large percentage of data is used for training the model and small portion of data is used for testing the model. Evaluation metrics for classification task. The first evaluation metric is accuracy. It is defined as the ratio of number of correct predictions to the total number of predictions. This is the fundamental metric used to evaluate the model. The formula used for the accuracy is true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. The second metric is precision and recall. Precision is the ratio of true positives to the summation of true positives and false positives. It basically analyzes the positive prediction. The formula is true positive divided by sum of true positive plus false positive. The drawback of precision is that it does not consider the true negatives and the false negatives. The next parameter is recall. It is the ratio of true positive to the summation of true positives and false negatives. It basically analyzes the number of correct positive samples. The next parameter is F1 score. It is the harmonic mean of precision and recall. It is seen that during the precision recall trade-off, if we increase the prediction, recall decreases and vice versa. The goal of the F1 score is to combine prediction and recall. The next parameter is evaluation metric is confusion matrix. It is an n-cross n matrix where n is the number of target classes. It represents the number of actual outputs and the predicted outputs. Terminologies used in the matrix are true positives, true negatives, false positive, false negatives. The next metric is AUC or ROSI curve. Area under curve is an evaluation metric that is used to analyze the classification model at different threshold values. The ROC curve is the receiver operating characteristics curve is a probabilistic curve used to highlight the model's performance. The curve has two parameters. One is TPR, true positive rate, and false positive rate.